Hello guys, welcome back to my video. So if you are new to this channel, please subscribe and turn the notification bell on so that you do not miss any of my videos. So in this video I'm going to be talking about the k nearest neighbor algorithm. So the k nearest neighbor is a supervised learning machine learning algorithm as the target variable is known. So if you remember, a supervised machine learning algorithm, a supervised machine learning problem is where we give a function, some features, and we also give it some labels, and then the function will learn from the features to map the features to map the features to the labels, so that if we give it a new feature, it will try to predict the new label. So the k nearest neighbor is a non-parametric algorithm, as it does not make an assumption about the underlying distribution of the data, so of the data points. So the k nearest neighbor algorithm is also considered as a lazy algorithm, as it does not have a training step. So later in the video I will illustrate how the k nearest neighbor algorithm works, so stay tuned. So what is k in k nearest neighbor? So the k in k nearest neighbor is a number used to identify similar neighbors for the new data points. So k nearest neighbor takes k nearest neighbors to decide where the new data point belongs to. So let's take an example. So let's say you have moved to a new place and you try to find new neighbors. You try to find new neighbors who have similar hobbies and who have the same goals as you. So that's how the k nearest neighbor works. So you start by you first look at the neighbors who are near, and then if you find some of the neighbors who have similar hobbies and passion, then they'll be your nearest neighbor. So that's how the algorithm works. So this decision is based on feature similarity. So that's what I was explaining. If you and your new neighbors have similar goals and passion, then the k nearest neighbor makes its decision based on feature similarity. So there is a higher. So let's take a look at this graph. So this graph is the graph of the f1 score against the k value. So as you can see, when k is equals to 1, we can see that the f1 score is low, or the accuracy is low. But we can also see that when k is equals to 5, the accuracy is higher. So when k is equals to 5, our model is more accurate. So this means that when k is equals to 1, our model is overfitting. So overfitting is a scenario whereby our model learns about the training features, but is unable to generalize when it's given new data. So it's like when you study for a test, and then let's say you cram examples, but when the test comes, you fail to generalize with the questions that are given in the test. So there is a higher error rate when k is equals to 1, hence the model overfits when k is equals to 1. So as we saw, the f1 score starts to drop for a higher value of k. The test set reaches a minimum error rate when k is equals to 5. As you can see, the accuracy increases when k is equals to 5, which means that it reaches a minimum error rate when k is equals to 5. So now let's take a look at how the k nearest neighbor works in terms of how the k nearest neighbor algorithm works in a classification problem. Oh, I'm sorry about that. So let's say we have this purple category. So we have this purple category with purple data points. And then let's say we have this green category. So in this case, the value of k is equals to 5. So let's say we want to find where this blue data point belongs. So what we do is we consider 5 nearest neighbors. So in this case, let's say, so let me just use the blue card. So we consider, let's say we just consider 5 nearest neighbors. So let's say these are the 5 nearest neighbors. So these nearest neighbors, we consider them in terms of distance. So we consider them in terms of distance from this blue data point. So in terms of distance from this blue data point. So how do we calculate the distance? So these data points are vectors. So how do we calculate these data points? How do we calculate the distance? So we use 2 methods to calculate the distance, or 2 parameters. We have what we call the Euclidean distance. We have what we call the Euclidean distance and the Manhattan distance. Sorry. So this is the Manhattan distance. So let's first take a look at the Euclidean distance. So let's say we have 2 vectors in a Cartesian plane. So we have a vector p1, which is given by x1 and y1, and another vector p2, which is given by x2 and y2. So how do we find the distance between these 2 vectors? Sorry, the distance between those 2 vectors. So we first find the distance in terms of the Euclidean distance. So I'll just call the Euclidean distance ED. So the Euclidean distance is the difference of x2 minus x1 squared plus y2 minus y1 squared. So that's how we calculate the Euclidean distance between these 2 vectors. So this is how our algorithm calculates the distance. It uses the Euclidean distance. So I hope I've clarified how the Euclidean distance is used to calculate the distance between two points in a k nearest neighbor algorithm. So the second method is we use what we call the Manhattan distance. So let's also consider our vector p1, which is x1, y1, and another vector which is with coordinates x2 and y2. So we first calculate the distance. First calculate the distance from this point to this point, which I will call A. We first calculate the distance of A, and then we calculate the distance of B, and then we add those distances. So first calculate the distance of A, and then we calculate the distance of B. So that's how the Manhattan distance calculates the distance between 2 points. So let's get back to our k nearest neighbor algorithm. So as we can see from our k nearest neighbor algorithm, we can see that we have 3 points which belong to the green class and 2 points which belong to the purple class. So we can see that the green class has more, this blue point is the green class has more points as compared to the purple class. So our blue point belongs to the green class, since the green class has more neighbors. So we have 1, 2, 3 neighbors as compared to 2 neighbors. So the value of k in this case must be in an odd number. Because if we say, let's say the value of k is 4, there will be a situation whereby we have 2 points from the green class and 2 points from the purple class. So this will cause confusion to our algorithm. So the value of k should always be an odd number. So now let us take a look at k nearest neighbor in terms of a regression use case. So in terms of a regression use case, the data points are from the same class. So in regression, we just want to calculate a continuous value. So let's say k is equals to 5 in this case. So we want to calculate the value of this purple class. Let's say this purple class. So we consider 5 nearest neighbors. Let's say these are the 5 nearest neighbors. So what we do is what the k nearest neighbor will do in terms of the regression problem is it will calculate. So it will calculate the average mean of all the nearest neighbors. Of all the nearest neighbors. So it will calculate the average mean of all the nearest neighbors. So the average mean of all these nearest neighbors will be the value of this purple point. So thanks for watching, guys. I hope this video helped you a lot understand the intuition behind the k nearest neighbor algorithm. So in the next video, I'm going to show you how to implement the k nearest neighbor using Scikit-Learn library. Thanks for watching, guys. Cheers.